Welcome back to WAEC class. I remain Engineer Shegun, and today we'll be talking about electroscope and electrophorus. Now, the electroscope is a device for testing and detecting charges. There are several types of electroscope, and one of them is the gold leaf electroscope. This is a diagram, a very simple diagram of an electroscope. This is the disc, can be made of brass, so we can call it brass disc. This is the brass rod, and then this is the brass rod extension. This is an insulating plug, and this is made up of metal, and then there's a glass here, so we can see the inside. Here is a gold leaf, and then here is the brass rod extension. There are several ways we can charge this electroscope. One of the most common ways we can charge the electroscope is by electrostatic induction. I'm going to talk about electrostatic induction shortly. But interestingly, if this electroscope is charged, it can be positively charged, it can be negatively charged. Once the electroscope is charged, I will know from this place. Let's say this electroscope is charged positively. This place will become positive, and of course this leaf will become positive. Positive and positive charge, they repel. So the leaf will diverge like this. So that's how I will know it is charged. If I just come and look at the leaf and it's diverged, then I'll know it is what? Charged. Even if it's negatively charged, and yes, negative, it's also what? Diverged. Or because like charges repel and unlike charges attract. Now, how do I use the gold leaf to detect or to test for charge? Let's say I have a gold leaf and I know the charge the gold leaf has. Let's say it's positively charged. And I bring a body. I don't know the charge of the body, or let's say the body is negatively charged. If the body is negatively charged and I bring it close to this gold leaf that is positively charged, the divergence here will decrease. So that's how I will know that this guy could be charged. But if I bring a positive charge and this gold leaf is positively charged, the divergence will increase. Then I can be sure that the body I brought here is positively charged because divergence has increased. The reverse is also true, that if this gold leaf were to be negatively charged and the body I'm bringing is negatively charged, divergence is going to increase. So I know that this guy is negatively charged. However, if the body is negatively charged and the body is positively charged, then divergence will decrease. But if the divergence is decreasing, it's not a sure way to determine the charge of the body you are bringing close. This is the reason. Because even if this body was not charged at all, if the body were to be neutral, divergence would have also decreased. So the sure way of knowing what charge the body has is when the divergence is increasing. Because this body can be negatively charged and this body can be neutral, divergence will decrease. This body can be negatively charged and the body will be positively charged and divergence will decrease. So because divergence is decreasing, I would not say it is because the body is negatively charged and divergence is decreasing. I can't say that this body is positively charged. It's inconclusive until I try it until there is a divergence in the gold leaf. So to summarize everything I've just said now, if I have a positively charged gold leaf electroscope and I bring a body to the electroscope and the body is positive, divergence will increase. If I have a negatively charged electroscope and I bring a negatively charged body to the electroscope, the divergence will increase. If I have a positively charged body and I bring a neutral body to the electroscope, the divergence will decrease. If I have a positively charged electroscope and I bring a negatively charged body close to the electroscope, the divergence will also decrease. So that is the summary of the idea. On this part, we have an electrophorus. Now the electrophorus is used also for storing charges. This electrophorus can be placed on top of an insulator, and this edge can be charged in various ways possible. This is an insulating handle, so that the charge of this body would not leave this handle is insulated, so that if you hold it with your hand, the charge cannot flow away because it is insulated, it's not a conductor. So the electrophorus basically is for storing charges, while the electroscope is for testing and detecting of charges. The next thing I would like to talk about now will be the ways of charging a body. You can either charge a body by friction, you can charge a body by contact, and you can charge a body by electrostatic induction. These are the three ways you can charge a body. By friction entails you rubbing the two bodies together. I can rub a glass rod with silk, and I can rub an ebonite rod with foam. If I rub a glass rod with silk, a positive charge is formed on the glass rod. And if I rub an ebonite rod with foam, a negative charge is formed on the ebonite rod. By contact, just simply means bringing the body close to each other, and they are touching. Contact is quite different from friction in the fact that in friction, I'm rubbing the body against each other. In contact, they are just touching. So for contact, I can have a body here, let's call it body A, or let's call it body B. And I have a body that is charged. Let's say it's negatively charged body A. If I use this body A to touch body B, if I bring body A in contact with body B, in the end, body B becomes negatively charged, having the same charge as body A. If body A were to be positively charged and body B is neutral, if I bring it in contact with body B, in the end, body B becomes positively charged. So charging by contact will have the same charge of the body you are using to charge it. The last form of charging a body is by electrostatic induction. Now, the electrostatic induction implies that contact is not required. So it's possible for me to have a body that is neutral. And this body is neutral. And when I say a body is neutral, it does not mean that there is no form of charge in the body at all. It just means that there are equal number of positive and negative charge. And if there are equal number of positive and negative charge, then the body is neutral because charges will cancel out. So let's say there are charges arranged randomly on this body, positive, negative, positive, negative, positive, negative, positive, negative, and like that. I bring a body that is, let's say, negatively charged close to this body. That's one of the steps of charging a body by electrostatic induction. You bring a charged body close to the body that is neutral. Let's say this is body B and this is body A that is negatively charged. What will happen is that once I bring this body A close to body B, all this charge will arrange themselves in such a way that all the negative charge will be repelled to this end, while the positive charge will be dragged to this end. Because of course we know that like charges repel and unlike charges attract. So in the end, we have positive, 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 and then we have negative, 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 negative. The next thing I'll do is this. I'm going to earth this body because these charges are pressed against this place and there's no way for them to go. If I earth means connecting a wire to it to the earth. Now once I earth this body, all this negative charge will flow away so that all I have left is all this positive charge that are here. Step one was that I brought a body close. Step two now is that I'm earthing it. After I've earthed, the next thing I will do is to remove the earthing. So I earth and remove the earthing. I will not earth and remove this charge body I'm bringing close because those charges that flow away can flow back. So after earthing, I will unearth. So I've removed the earthing. Remember that there's this positive charge here. The next thing I need to do now is to remove this body A that I brought close that was charged. In the end, once I remove this body A from it, all this positive charge will spread out and then this body becomes positively charged. The reverse would have been the case if I brought a positive charge close, the body would have been negatively charged. So you see, I have body A, body B. Body A is charged and body B is neutral. Body B is going to end up having the opposite charge of body A once I'm done charging it with electrostatic induction. The step of electrostatic induction, I can summarize it quickly. First, you are bringing a charged body close to the neutral body. Second, you earth it. Third, you remove the earthing. And last, you remove the charge you brought close. And that body is going to have the opposite charge of the charge you brought close to the neutral body. And this is all for the foundation of electrostatics. In our next class, we'll talk about current electricity.